All right, let's call this boardroom session to order. Welcome to the Explainer. Today we're auditing one of the most notoriously mismanaged assets in the entire Cambridge Mathematics 9709 syllabus. And that is Section 5.5, the normal approximation to the binomial distribution, specifically focusing on the continuity correction. Listen, if you're targeting that top-tier C-suite A-star grade, you cannot afford to be sloppy. You have to treat every single past paper question like a high-stakes market pitch, executing with absolute, undeniable precision. The board of directors, or in our case, the Cambridge examiners, consistently report that missing the continuity correction is a critical failure point. It is a massive liability that tanks student valuations year after year. So we're going to fix that right now. We are going to build an exhaustive, bulletproof, structural framework so you never drop these marks again. We're aiming for maximum return on investment today.
Here is today's rigorous agenda. First, we'll review the strict examiner mandates. Then, we'll move into deconstructing a common failing mistake. Next, we'll establish the structural balance of an elite answer. After that, we'll run a live knowledge check to audit your compliance. And finally, we'll lock in our core corporate pillars with the final checklist.
Okay, let's start with a direct, non-negotiable mandate straight from the Cambridge Principal Examiner Report. It explicitly states that candidates referencing cross-topic connections achieve significantly higher marks. What does that actually mean for your bottom line? It means connected, conceptual understanding is absolutely mandatory for a top-band valuation. You cannot treat the binomial distribution and the normal distribution as isolated departments. They interact. The binomial distribution deals with discrete data. Think of it like chunky, countable, specific building blocks. You can't have half a block. But the normal distribution, that deals with continuous data. It's a beautifully smooth, infinitely measured curve. So, when you try to use that smooth, continuous curve to approximate those chunky, discrete blocks, you have to formally account for how they actually fit together. That vital adjustment, that's your continuity correction. If you ignore it, your entire mathematical methodology just falls apart, and your proposal gets rejected.
Let's transition into Act 1, deconstructing a liability proposal. We need to see exactly where these pitches usually crash and burn.
I want you to imagine a classic past paper scenario, our market opportunity for the day. A candidate is asked to find the probability that a value X is strictly greater than 40. Now they do the initial legwork. They calculate the mean, they calculate the variance, and they initiate the normal distribution model perfectly. But then they execute a fatal procedural error. They standardize the value 40 directly into their z-score formula, completely ignoring the continuity correction. The result? The executive value meter immediately crashes to 0. 0 marks for that calculation stage. Why? Because you have to think about the physical space that discrete number 40 occupies. It actually represents a solid block of space spanning from 39.5 to 40.5. If the regulatory requirement is strictly greater than 40, you absolutely cannot start your continuous measurement exactly at 40, because if you do, you accidentally include the top half of the 40 block. You have to start completely past it at 40.5. Missing that 0.5 shift zeroes out your accuracy marks instantly because you've broken the pure logic of the math.
Let me break down exactly why a generic text block is a massive liability compared to a high-value analytical pitch. Take a look at the difference here. On one side, we have a low-value bare-bones answer. It just lists naked numbers without context, throws down a z-score formula without even declaring the distribution parameters, and spits out a final decimal. It's sloppy. Now contrast that with a fully justified C-suite level method. A top-tier response explicitly states the conditions up front. Since n times p is greater than 5 and n times q is greater than 5, the normal approximation is valid. Boom, market compliance achieved. It clearly defines the new parameters, applies the precise continuity correction with crystal clear notation, and perfectly links the final probability back to the original context of the question. Cambridge examiners prioritize analytical depth. You need to do the heavy lifting on the page to prove to them exactly why your math works.
That brings us right into Act 2, the consultant co-op debate, where we examine the internal structural battle every student faces during an exam.
Backstage at any high-pressure exam, candidates usually split into two flawed personas. Let's call them junior associates Alex and Sam. Now, Alex is what we call the raw calculator. Alex processes massive volumes of raw factual data, quickly crunching the n and p values to get the mean and variance, and just shoves those numbers into the standard normal equation to get a quick decimal. Massive data output, but absolutely zero evaluation of market risks or constraints. Then you have Sam. Sam is the theorist. Sam pitches brilliant creative concepts. Sam perfectly understands that because n times p is greater than 5, the approximation holds, and even knows the continuity needs adjusting. But Sam severely lacks the hard formulaic formatting on the page to actually prove it step by step. If Alex and Sam were pitching to the board, they'd both get rejected. Alex has no framework, and Sam has no data execution.
Through rigorous debate, our associates realized that to meet strict Cambridge regulatory compliance, they have to merge their assets. They must explicitly rewrite their core thesis out loud on the page. You have to declare your causal relationships. The binomial parameters meet the size threshold, therefore we seamlessly transition to the normal distribution model. Then, you have to back it up with hard evidence, structure the exact variance calculation, execute the standard deviation square root within the z-formula, and deliberately write down your 0.5 continuity correction to physically bridge that discrete to continuous gap. By forcing this strict evidence-based reasoning, you shift from simply doing math to delivering an undeniable corporate valuation.
Let's move to Act 3, the midpoint valuation reboot and feed calibration. Now, right before we finalize the structural architecture of our perfect response, we need to pause for a mandatory feed calibration. Look, before we see if this response can secure a top band valuation, you need to ensure your personal academic assets are properly managed. Subscribe to Ace the Exams at Ace the Exams right now and turn on all notifications. No matter if your focus is Cambridge, IGCSE, O-Levels, AS, or A-Levels, this channel is your weekly board seat to secure elite grades. Okay, back to the pitch. The associates hit a roadblock because they lose sight of the core objective. Never forget that 0.5 shift is everything. It is the literal, physical bridge between those chunky discrete blocks and that smooth continuous curve. Getting the direction of that 0.5 shift wrong doesn't just lose you a point. It means you've completely failed the fundamental logic of the audit.
So, I'm going to step in and give you the ultimate structural power-up template to process any normal approximation problem. Step 1. Deconstruct the question. What is the actual deliverable? A probability, a bound, an expected value? Step 2. Extract relevant data. Pull out your n and p with 0 errors. Step 3. Select the analytical framework. You must explicitly write down that NP and NQ are both greater than 5. That is your legal clearance to use the normal distribution. Step 4. Execute with clear notation. Calculate your new mean and variance, and absolutely ensure you apply the continuity correction to your target value before finding that z-score. Step 5. Present with correct terminology. Tie the final decimal back to the specific context, whether you're auditing manufacturing defects, surveying voters, or measuring crop yields. Watch as we rewrite the response line by line using this exact flow. It creates a bulletproof chain reaction. First, the condition. State exactly why the approximation is valid. Next, the parameters. Define the new mean and variance clearly. Then the correction. Explicitly show the discrete value shifting by exactly 0.5. After that, the calculation. Standardize to your z-score flawlessly. Finally, the context. Link it back to the real world. The examiner is not hunting for a floating right answer somewhere in the margins. They want a highly profitable A-star asset that guides them to the conclusion through an undeniable logical narrative. We are now entering Act 4, the live interactive compliance audit. Let's see if you can execute under pressure.
I am initiating an asset inventory scan right now. Let's look at this scenario. You have exactly 60 seconds on the boardroom clock to extract the highest value data point. Imagine you're auditing a supply chain, and you need to find the probability that less than 25 items are defective. What is your precise continuity correction? Think about it. In a discrete, blocky world, what is the absolute highest integer that is strictly less than 25? It's 24. So the discrete block we must include is 24, but we absolutely cannot touch any part of the block for 25. To capture the entirety of the 24 block on our continuous curve, we must measure all the way up to its upper boundary. Therefore, the exact continuity correction value we must standardize is 24.5. If you chose 25.5 or 24.0, your methodology is instantly rejected.
Before our final practical test, I'm revealing the top 3 fatal mistakes directly from the principal examiner reports. These are your biggest liabilities. Warning 1. Forgetting proper format. If you don't clearly declare the new mean and variance, you breach marking regulations and lose the method mark. Warning 2. Forgetting to check presentation. This means either leaving out the continuity correction altogether or flipping your greater than and less than inequality signs when making the conversion. Warning 3. Answers not specific to context. Do not give generic math answers. Always link your final probability to the exact corporate scenario described in the prompt.
Let's do one more audit. Spot the liability.
I'm displaying a flawed response paragraph on the screen. The candidate calculated the mean perfectly. They calculated the variance perfectly. They even stated the normal approximation is valid, but look closely at the probability statement. The original question asked for the probability that x is at least 15. The candidate evaluated the area starting exactly at 15. Where does the logic break down? Listen, at least 15 means x is greater than or equal to 15. That means the discrete block of 15 must be included in your calculation. Therefore, your continuous boundary must extend down to capture the very bottom edge of that 15 block, which is 14.5. By using exactly 15, the candidate essentially sawed the 15 block in half. That is a total failure of conceptual understanding, and the marking scheme demands an automatic 0 for that stage.
Let's move into Act 5, Securing the Deal. We are bringing everything we've built to the forefront.
When Alex and Sam officially present their newly engineered flawless response paragraph to the board, the executive value meter instantly hits the maximum $1 million A-star mark. It is a 100% execution. The transition from binomial to normal is justified with the NP greater than 5 rule. The mean and variance are declared, the continuity correction expands the boundaries perfectly, the z-score is mathematically pure, and the final probability is explicitly contextualized. This satisfies every single higher-order assessment objective and proves you possess elite-level, connected mathematical understanding.
To guarantee you leave this session with a bulletproof methodology framework, I am distilling this entire audit into 3 core corporate pillars. Number 1, the due diligence scan, or decoding. Identify command words, extract N and P, and determine if a normal approximation is required. Number 2, the resource allocation matrix, or timing. Allocate proper time to build your mathematical argument step by step on paper, instead of just rushing to punch numbers into a calculator. Number 3, the final compliance audit, or your review checklist. Ask yourself, did I apply the continuity correction? Did I shift by 0.5 in the correct direction? Is my answer contextualized? Follow this, and you secure the deal every time.
That concludes our boardroom briefing on the normal approximation. We've audited exactly how a tiny 0.5 shift acts as the ultimate gatekeeper for top grades. But let me leave you with a final provocative thought. Mastering this isn't just about memorizing a formula to survive an exam. It is about deeply visualizing the friction between chunky, separate data points and a smooth, continuous reality. So ask yourself, are you just memorizing the steps to fake your way through the pitch, or do you actually understand the why behind the math? Because understanding that beautiful logic is exactly what separates the rote memorizers from the elite mathematicians. Now, to secure your next elite board seat, subscribe to @ACEXams right now, enable that notification bell, and drop a comment below with your target grade, your qualification tier, and your subject. Class dismissed.